All right, moving on to number 9. Number 9 is an object that's being pulled at an angle, and the force of pull, or the tension, because you're pulling a rope, is 200 newtons. That means you're pulling a little bit up, that's T in the Y. You're pulling a little bit left, that's T in the X. Other forces acting on this, a normal force is pushing up because it is on the ground. Friction's pulling to the right because the ground is causing friction between the object and it. And force of gravity pulls straight down. So step 1, I drew all of my arrows, that's complete. I know that my right stuff is positive stuff and my left stuff is negative stuff. Up is positive, down is negative, so that's step 2. Step 3, I gotta break this tension, which is at an angle, 30-degree angle to be specific, into its X and Y pieces. So how much am I pulling to the left? If I take a look at this triangle, tension in the X is the adjacent side, so I'm gonna use cosine, because TOA, the cosine is the adjacent over the hypotenuse, which is how hard you're actually pulling, which is 200. So that's where this equation comes from. Tension in the X equals the cosine of 30 degrees times the hypotenuse, which is 200, how hard I'm pulling. Plug in my calculator, and I get 173.2 newtons. Tension in the Y, that's the opposite side of this triangle, so that's why I'm using sine down here. Tension in the Y is sine of 30 times 200 newtons, or 100 newtons is how much I'm pulling upward. Adding up my left and right things, my right arrow, only arrow pointing to the right on this drawing is force of friction, that's why it's positive in my equation. Only arrow pointing directly to the left is tension in the X, that's why it's minus in my equation. I'm out of left and right arrows, so that's 0. My right stuff equals my left stuff. And we solve for tension in the X in step 3, I have it right here. So friction equals tension in the X, then friction must equal 173.2 newtons. Up and down. Up arrow, normal force, which is why it's positive. A lot of people forget you're pulling upward. Don't forget tension in the Y. That's right here. We solved for it in previous step. So that's why that one's positive, and gravity is straight down. All those added up equals 0. So my up stuff, normal, equals my down arrow, force of gravity, minus my other up arrow, which is Ty. I just did a little algebra, subtracted Ty to the other side, added force of gravity to the other side. That's how I got this right here. Force of gravity is mg. We've been using that a lot, so you should know it by now. And Ty, we solved for it earlier, is 100 newtons. Plug in. Mass is 50 kilograms. G is 9.8 meters per second squared. Ty is 100 newtons. And my calculator will tell me that my normal force is 390 newtons. Now we're going to solve number 10. Number 10, there's a normal force acting on this. There's a force of gravity acting on this. There's a force of friction acting on this. And this is an object that you are pushing down and to the right with a force of 30 newtons. I'm going to break this force of push that's down and at an angle into its components so I can find how much I push to the right and how much I push down. Trying to find my force of pull or push in the X. That's the adjacent side of this triangle. So I'm going to use cosine just like I did in the previous problem. And that's where this comes from. Force of push in the X equals cosine of 20 degrees times 30 newtons. Plug that in my calculator, I get 28.2 newtons for force of push in the X. In the Y, that's the opposite side, so I'm going to use sine. That's where this equation comes from. Force pull in the Y equals the sine of 20 degrees times 30 newtons, and my calculator tells me that that's 10.3 newtons that I'm pushing downward. Adding up my left and right stuff, my right arrow is my force of push in the X. You can see it right here in my drawing. My left arrow is the force of friction. That's why it's minus in my equation. All my right stuff minus my left stuff equals 0, or my right stuff equals my left stuff. Since we already solved for force of push in the X direction, I know it's 28.2 newtons. That must be what force of friction is. Left and right is done. Moving to the up and down. The normal force is upward. You're pushing downward, that force of push in the Y. Notice that's down, so that's why it's a minus. Force of gravity is down. My up stuff minus all my down stuff equals 0. So my up stuff equals all of my down stuff. I'm now going to plug in what I know for force of gravity. That's mg. And force of push in the Y direction we solved for in a previous step is 10.3. We did that right over here in case you forgot. So my normal force equals 10.3 newtons plus 10 kilograms times 9.8 meters per second squared. My calculator will tell me that my normal force has to be 108.3 newtons.